Okay, we are here for video lab number 4 today. We'll check out our audience here. And let's meet the team. Who are you?
Nicole.
Who are you?
Tim.
Who are you? Scott. Okay. And who can tell us from the audience, what's today's lab all about? What are we trying to figure out today?
Cohesion.
Cohesion. And who can give me a definition of that word? What do we mean by cohesion?
Like, when things like go together because they have this, like, the same molecules?
Yes, the force of attraction between like molecules. What type of molecules are we going to use in today's experiment?
Water.
Okay, and who give me the formula for that chemical?
H2O.
And who can tell me what elements make up that chemical?
2 parts hydrogen, 1 part oxygen.
Okay, so let's move over to Nicole, who has the H2O. And if you could put like 5 or 6 drops in different places on the wax paper, using a piece of wax paper here. Okay, now, I want you to put some big ones in there also. Don't be afraid to glob it. That's good. Okay, what's unusual about the relationship right now between the water and that wax paper? Something strange?
The water just sits on top of the wax paper. It doesn't penetrate through it.
Right, and what prevents the water from penetrating the paper?
The wax on the paper?
Yes, okay, the wax, the coating prevents it from going in. Okay, now Nicole, what I need you to do is to pull up the paper a little bit so that one of those water droplets can come in contact with another one. Okay, let's try one more.
It's hard.
Oh, blocking the camera.
Sorry.
It's okay. Yeah, keep going, you. There you go. Okay. So what happens when the water droplets come in contact with each other? Yes?
They just make one big drop.
And what causes that to take place? Why did they do that?
Cohesion.
Say it loud.
Cohesion.
Right. This is the example of cohesion. Okay, very good. Now, we need Scott to put the comic strip under the paper while the water's still on it. Just pull that paper towards you so that you can look through the water droplet at the comic strip underneath. So why don't you do that, Scott? And tell us, how does that water droplet affect the comic strip that's underneath?
It magnifies it?
Okay, let's talk about magnification. Why would a water droplet magnify something?
Because it's curved.
Okay, and what happens to light as it goes through a curved, actually this is like a lens right now. What do we call a curved lens? A lens that curves outward.
Convex lens?
Yes, a convex lens, all right? Now what happens to the light when it hits a curved piece of glass? Yeah, but before it does that, in order to magnify, what happens to the light?
Bends?
It bends. And when it bends, it crisscrosses at a point called what?
Focal point.
The focal point. And 2 things can happen to it at the crisscross, depending on whether you're before or after the crisscross. What's one thing that could happen to the image?
It could turn backwards, like upside down.
Yes, and what do we call an upside-down image?
Virtual.
Nope, nope. Upside-down image?
Real image?
Nope.
Inverted?
It's called an inverted image, okay? So one thing that can happen is it turns upside down. What's the other thing that can happen?
It can enlarge.
Yes, and that's what happened right over here. What do we call that type of an image that enlarges?
Virtual.
Yes, it's not really there because the thing didn't get really bigger, right? Nothing is bigger in front of you, so it's a virtual image. Okay. Scott, what I want you to do right now is to take a look through 2 of those droplets, one big, one small, and tell me which one magnifies more.
The small.
Okay, let's talk about that. Why would a small droplet magnify more than a big droplet?
It has a bigger curve.
Right, and why would a small droplet have a bigger curve than a big droplet?
Because the bigger droplet it has more weight, so it would flatten down.
Okay, and if it flattens out, what happens to its magnification? It loses. Okay, so that's the reason a small droplet magnifies more. Okay, now what I want you to do is to pass this over to Tim. He's got a magnifier with him. And Tim, you just want to give him the, take the top off. He just wants to use it on top of the comic strip. Tim, I want you to take a look at the different colors that are in that comic strip, all the different colors, and see if there's something unusual about some of the colors.
There are dots over a background?
Yes, so some of the colors are really not existing. In fact, there's only 3 colors on the comic strip. What are the 3 colors that are on the comic strip?
Red, yellow, and blue.
And what do we call those colors?
Primary.
So how do we produce a color like green? This is the quiet side of the room? Yes.
Blue and yellow.
Blue and yellow. In other words, blue dots with a yellow background, or yellow dots with a blue background, or a combination of yellow and blue dots. How would you make orange?
Red and yellow.
Yes, say it loud.
Red and yellow.
And how would you make purple? Purple.
Blue and red.
And how would you make pink? Pink.
White, red.
Okay, now white. That's not a color. What do we call white? Has a special name to it.
Tint.
Well, not a tint, because you can have colors that are tints as well.
Shade.
It's a shade. What other shades are there besides white? And how about if you put those 2 shades together, what do you end up with?
Gray.
Gray. So if you take combinations of primary, secondary, and shades, you can create all the different colors that you find on the comic strip. Now, not only can colors be created with dots, but images can be created with dots. Give me an example of an image that has been created by dots. What would be an example of something like
Pictures, like not in the ones that you get from like a camera, but like regular pictures,
that you would find where?
like maybe newspapers.
Okay, a black and white photograph in a newspaper. Where else?
If you download a picture like on a computer and print it out.
Yes. Okay, those particular dots have a name to them. What are the dots from a computer called? Pixels. Okay, where else might you find dots producing images?
Comic strips.
Comic strips. Okay, where else?
Magazine.
Okay, color photographs in a magazine. What piece of equipment in your house might have dots?
Television.
If you were to put your eye on the screen of a television and looked in, there would be dots inside. How about if you were in a mall? What could you get out of a mall that had an image based on dots?
Pictures.
Pictures that were taken and used from a what?
Picture taker, I guess.
Well, no, not just regular pictures, because we said the regular pictures don't have dots.
That little blue thing that they have.
Yeah, but what do they use to create the picture? Common piece of equipment that everybody has practically.
Camera.
No?
Computer.
A computer. Does anybody over here have a computer picture? Oh, you do? Okay, let's see. Tim, why don't you put it over here? Just the picture we only need. This is a picture you got in the mall. Which one is you in this picture?
They all kind of like blocked it out, so.
They got in the way.
Behind them.
Oh, you're okay. Now, if we get really close on these pictures, we're going to find that these pictures are not really pictures, but they're just nothing more than dots. What we're going to do is set the camera on something called macro, which allows us to get right in on it, and we should be able to see the dots. I'm going to shut this off and put it back on again. A close-up of the face of this young lady who was in front of Tim. Did you know her name, Tim?
No, she's one of the other girl's friends.
Okay. And you can see that it is nothing more than a series of dots. Good job on this. And this ends video lab number